Hello all, this is the video about the microcontroller unit controlled data logger 4-channel analog. What I can tell you about it is that this is the microcontroller. It's consisting of a PIC 18LF13K40 3x3 unit. This is an SD card of 32 megabytes. And this is a controller chip for the serial connection, a MAX232, RS232 interface into the PC. The serial connection is only for getting information from the logger or to the logger. Here we have a yellow button, it's the reset button, the green light, LED, after the reset, if the LED burns, the SD card is okay. The red LED and the blue button. The blue button together with the yellow will automatically start the system to record any data. The red LED will say when the data is all recorded and the SD card is full, which it will take about 36 hours. 4-channel analog inputs. Here I created some potentiometers to make a variable in voltage to just check if the inputs are working, and it works, I can assure you. There's a little program involved running under Windows in which you can create the first sector of the SD card, which is a configuration sector. It holds information about the delay time between measurements and the number of channels. Okay, I'm going to show you the program now and we will start up the data logger. This is the program which controls the data logger. What we first are going to do is set the configuration sector on the SD card for measurements. As you can see, the logger config is set to 10 milliseconds intervals. That's my intention to measure it quickly, so just for testing. 10 milliseconds, it's about 10 milliseconds because there's a lot of routines in between. The time, 4 channels, all 4 channels will be used. These are just references, 52 and here we will put 203 and then we are going to erase the chip. It says, would you really like to continue? Yes. And here you can see that the config is written, so it should be okay. This is a hyperterminal screen just to check the communication from the logger. The logger will send every measured value through the RS232 interface to the program, so it can be viewed what it does, what it will do, and how you can control it. I'm going to reset the logger now. And you will see in the screen the menu, which is sent by the microcontroller, by the way. So if you put a key 4 in here, it will bulk erase, and if you put key 2 in here, it will read by block. You need to fill in the block number. It's configured for blocks of each 512 bytes. So if you read the block number 0000, it will read the config. I can do that, that's no problem. 2. Have to activate the window. 2 received 50,0000. There it comes. That's the config. And it can do that with every block till the 32 megabyte limit, which is a bit lower than 32 megabytes, but that's not of any use. Okay, I'm going to start the logger to measure values. Reset, the blue one in, yellow loose, and there it goes. You can see the changing of the values. When I turn the potentiometers, you can see the voltage go up and down. Okay, I will stop the logger now. Restart it. Yeah, there it goes. This is the menu. The green LED is now on. And I can read a block if I like. Read by block 2. Oh, sorry, I have to activate the window again. 2. And then 0030, and there are the values for that block. And you can read all blocks by hand, or the program will do it in the same way. Here we are back at the program after measuring. The logger is connected. What I can do is read the first 20 sectors by hand just to see what happens, so we will do that. Here is the communication window just for debugging. What you can see, all the values coming through till 13 hex, and these are the values measured with the potentiometers turning. This is the first sector. You can see the configuration here. 10 is the 10 milliseconds interval. 0 is the high bit of the 10 milliseconds. You can also use, you can go till 65535 milliseconds per measurement, which is quite a lot. These are two reference lines, as set here, just for referencing. Okay, these are the values. You can see here by the colors, channel 1 yellow, channel 2 green, and all the rest. You can also read the next information, but it takes some time to read in because of the serial interface. I was trying to create it for USB, but that doesn't work yet. I'm still working on that one. Okay, what we are going to do now, we are going to save the information measured in the logger. It's nice to put in the start time of measuring and the end time of measuring, because when you do this, the program will automatically calculate the times of changes. You will see a time numbering scale here above. I will show you. Just put in a time, for instance 10:00 and 12:00, which was about 2 minutes, I don't know. Okay, here we go. Saving 2, test 2. Seems to be a nice gesture. There it goes. It takes a bit of time. You see here, it reads all the sectors from the SD card till the end of measuring. It can see that because when you erase the SD card, it will all get the value 255 per byte. When the program sees all 255s, it stops reading because it's the end of the measurement. So it will not go all the way, I believe. If it does, it takes about an hour. But what's an hour on 24 hours of measurement? It's not much. You can see the address is also in the hyperterminal window, because it will put out the blocks. This is a block number, 512 bytes each, which makes a totally of 32 megabytes. Okay, it's all read in. Now we are going to load the same data, which is 2, and you can see here the timetable. 0241, you can see? It's all seconds. It's not that... it has a big tolerance, but it's something to work with. What we can do here in the search window, we can search for all channels. The program automatically, when you put here 2 channel, it will only activate these 2, and you can measure on certain variables, larger than a variable, an AND or an OR. And when you press the search, it automatically searches for the next available bytes in conjunction with each other. So, which is quite nice. Okay, you can scan through the system. It's going a lot faster now, as you can see. You can see the values in the display. What the values are. It's digitally values. It's not the values you should measure directly. It's just digital. The top value is 255, the bottom 0. So, as told, I'm still working on a USB version, and I'm also working on a zoom function in the program to zoom in or out on the measurements. Okay, this is it for now. If you want updates or you want to download, it's free, and just check skumari.com or skumari.nl. Have fun. Bye bye.